An event-driven process chain is a type of flowchart used for business process modeling. EPCs can be used for configuring an enterprise resource planning implementation, and for business process improvement. Usage for control of work share with instances of autonomous workflows in workflow management is possible, but not yet implemented. The event-driven process chain method was developed within the framework of Architecture of Integrated Information Systems by August-Wilhelm Scheer at the Institut für Wirtschaftsinformatik, Universität des in the early 1990s. Overview: Businesses use event-driven process chain diagrams to lay out business process workflows, originally in conjunction with SAP R/3 modeling, but now more widely. It is used by many companies for modeling, analyzing, and redesigning business processes. The event-driven process chain method was developed within the framework of Architecture of Integrated Information Systems. As such, it forms the core technique for modeling in ARIS, which serves to link the different views in the so-called control view. To quote from a 2006 publication on event-driven process chains, an event-driven process chain is an ordered graph of events and functions. It provides various connectors that allow alternative and parallel execution of processes. Furthermore, it is specified by the usages of logical operators, such as OR, and XOR. A major strength of EPC is claimed to be its simplicity and easy-to-understand notation. This makes EPC a widely acceptable technique to denote business processes. The statement that event-driven process chains are ordered graphs is also found in other directed graphs for which no explicit node ordering is provided. No restrictions actually appear to exist on the possible structure of EPCs, but non-trivial structures involving parallelism have ill-defined execution semantics. In this respect, they resemble UML activity diagrams. Several scientific articles are devoted to providing well-defined execution semantics for general event-driven process chains. One particular issue is that EPCs require non-local semantics, that is, the execution behavior of a particular node within an EPC may depend on the state of other parts of the EPC, arbitrarily far away. Elements of an event-driven process chain. In the following, the elements used in event-driven process chain diagram will be described. Events are passive elements in event-driven process chains. They describe under what circumstances a function or a process works or which state a function or a process results in. Examples of events are requirement captured, material in stock, etc. In the EPC graph, an event is represented as hexagon. In general, an EPC diagram must start with an event and end with an event. Functions are active elements in an EPC. They model the tasks or activities within the company. Functions describe transformations from an initial state to a resulting state. If different resulting states can occur, the selection of the respective resulting state can be modeled explicitly as a decision function using logical connectors. Functions can be refined into another EPC. In this case, it is called a hierarchical function. Examples of functions are capture requirement, check material and stock, etc. In the event-driven process chain graph, a function is represented as rounded rectangle. Process owner is responsible for a function. The process owner is usually part of an organization unit. It is represented as a square with a vertical line. Organization units determine which organization within the structure of an enterprise is responsible for a specific function. Examples are sales department, procurement department, etc. It is represented as an ellipse with a vertical line. Information, material, or resource object. In the event-driven process chain, the information, material, or resource objects portray objects in the real world, for example business objects, entities, etc., which can be input data serving as the basis for a function, or output data produced by a function. Examples are material, order, etc. In the EPC graph, such an object is represented as rectangle. Logical connector. In the event-driven process chain, the logical relationships between elements in the control flow, that is, Events and functions are described by logical connectors. With the help of logical connectors it is possible to split the control flow from one flow to two or more flows and to synchronize the control flow from two or more flows to one flow. Logical relationships. There are three kinds of logical relationships defined in event-driven process chains: branch-merge. Branch and merge correspond to making decision of which path to choose among several control flows. A branch may have one incoming control flow and two or more outgoing control flows. When the condition is fulfilled, a branch activates exactly only one of the outgoing control flows and deactivates the others. The counterpart of a branch is a merge. A merge may have two or more incoming flows and one outgoing control flow. A merge synchronizes an activated and the deactivated alternatives. The control will then be passed to the next element after the merge. A branch in the EPC is represented by an opening XOR, whereas a merge is represented as a closing XOR connectors. Fork and join correspond to activating all paths in the control flow concurrently. A fork may have one incoming control flow and two or more outgoing control flows. When the condition is fulfilled, a fork activates all of the outgoing control flows in parallel. A join may have two or more incoming control flows and one outgoing control flow. A join synchronizes all activated incoming control flows. In the event-driven process chain diagram, how the concurrency achieved is not a matter. In reality, the concurrency can be achieved by true parallelism or by virtual concurrency achieved by interleaving. A fork in the EPC is represented by an opening AND, whereas a join is represented as a closing and connectors. OR and OR relationship corresponds to activating one or more paths among control flows. An opening OR connector may have one incoming control flow and two or more outgoing control flows. When the condition is fulfilled, an opening OR connector activates one or more control flows and deactivates the rest of them. The counterpart of this is the closing OR connector. When at least one of the incoming control flows is activated, the closing OR connector will pass the control to the next element after it. Control flow. A control flow connects events with functions, process paths, or logical connectors, creating chronological sequence and logical interdependencies between them. A control flow is represented as a dashed arrow. Information flow. Information flows show the connection between functions and input or output data, upon which the function reads, changes or writes. Organization unit assignment. Organization unit assignments show the connection between an organization unit and the function it is responsible for. Process path. Process paths serve as navigation aid in the EPC. They show the connection from all to other processes. The process path is represented as a compound symbol composed of a function symbol superimposed upon an event symbol. To employ the process path symbol in an event-driven process chain diagram, a symbol is connected to the process path symbol, indicating that the process diagrammed incorporates the entirety of a second process which, for diagrammatic simplicity, is represented by a single symbol. Example: as shown in the example, a customer order received is the initial event which creates a requirement capture within the company. In order to specify this function, sales is responsible for marketing, currency, etc. As a result, event requirement captured leads to another new function, check material on stock, in order to manufacture the productions. All input or output data about material remains in the information resource. After checking material, two events may happen with or without material on stock. If positive, get material from stock. If not, order material from suppliers. Since the two situations cannot happen at the same time, XOR is the proper connector to link them together. Tools. There are a number of tools for creating EPC diagrams: ARIS toolset of IDS Scheer AG, Free Modeling Tool ARIS Express by IDS Scheer AG, Adonis of BOC Group, Maven Rules of Maven BV, Business Process Visual Architect of Visual Paradigm, VICO of Microsoft Corporation, SemTalk of Semtation GmbH, or Bonaparte by Picos GmbH. Some but not all of these tools support the tool-independent event-driven process chain markup language interchange format. There are also tools that generate EPC diagrams from operational data, such as SAP logs. EPC diagrams use symbols of several kinds to show the control flow structure of a business process. Meter model of event-driven process chain. Although a real process may include a series of stages until it is finished eventually, the main activities remain similar. An event triggers one function, and a function will lead to one event. Meanwhile, an event may involve one or more processes to fulfill, but a process is unique for one event. The same goes for process and process path. As for the function, its data may be included in one or more information resources, while organization unit is only responsible for one specific function. See also, flowchart, Petri net, swim lane, workflow, references. External links. Open source EPC modeling tool BFLOW Toolbox, LibreOffice Gallery symbols for drawing event-driven process chain diagrams, symbols for drawing event-driven process chain diagrams, event-driven process chains for better flows, free EPC modeling tool by August-Wilhelm Scheer, Java implementation of EPC in the JBPT library.